Hello everyone and welcome back to Moo Techie. It's fantastic to have all the dairy technologists and cheese enthusiasts with us for another class. This is class 12 in our cheese technology series, and today we're exploring a truly iconic cheese that has taken the world by storm, mozzarella. Mozzarella cheese was originally manufactured from high-fat buffalo milk in Italy. However, in European countries and the USA, it is also commonly made from cow's milk. Its global popularity surged after World War II, when pizza restaurants in the US began to establish a market outside of traditional ethnic communities. By the mid-1970s, pizza was firmly established as a popular food with broad appeal across the United States. More recently, American franchise restaurant chains have expanded aggressively into other countries, dramatically increasing the popularity of pizza in Europe, South America, and Asia. As a direct result, the worldwide demand for mozzarella has skyrocketed. It is now produced in many countries, including the US, Italy, Argentina, Australia, Brazil, Canada, France, Ireland, the UK, and New Zealand. Mozzarella belongs to a class of cheeses known as pasta filata, or stretched curd cheeses. This category involves the principle of skillfully stretching the curd in hot water to achieve a characteristically smooth texture and grain in the final cheese. Mozzarella itself is a soft, white, unripened cheese that is often consumed shortly after manufacture. Its exceptional melting and stretching characteristics are highly appreciated, making it a key ingredient in the preparation of pizza. The basic manufacturing technology for mozzarella cheese is similar to that of cheddar cheese, but with some important variations. When made from buffalo milk using a culture, the process begins with milk that is standardized to 4% fat and then pasteurized. This milk is put into a cheese vat. A starter culture containing Streptococcus thermophilus and Lactobacillus bulgaricus in a 1:1 ratio is added to the milk at 31 to 35 degrees Celsius at a rate of 2%. After ripening for about 50 minutes, rennet is added at a rate of 1.0 grams per 100 liters of milk. After about 30 minutes, the curd is set. It is then cut and allowed to stand in the whey for 10 to 15 minutes. The curd is then cooked gradually by increasing the temperature to 40 to 41 degrees Celsius over 30 to 35 minutes. The whey is drained off and the curd is allowed to ripen until it reaches an acidity level of 0.75 to 0.80%. At this stage, the curd is immersed into hot water at 80 to 85 degrees Celsius. After about 2 to 3 minutes, the curd is kneaded, stretched, and molded. This step is crucial for developing the proper body and texture. The molded cheese is then dipped into chilled water at 5 to 10 degrees Celsius for cooling, which can take 1 to 12 hours. The cheese is then transferred to a brine solution with a 20% concentration at a refrigeration temperature of 8 to 10 degrees Celsius for salting. The pH of the brine solution is maintained at 7.6. After the cheese attains the desired salt level of 1.6 to 1.8%, it is taken out and dried in a cold store. We can visualize this process through a flow chart. It starts with milk, which is filtered and clarified. It is standardized to 3 to 4% fat and pasteurized at 63 degrees Celsius for 30 minutes. The milk is then cooled to 31 degrees Celsius. The starter culture, a 1:1 blend of S. thermophilus and L. bulgaricus, is added. Rennet is added at 1.0 to 1.5 grams per 100 liters of milk. The curd is cut, cooked to 42 to 44 degrees Celsius, and then pitched. The whey is drained, and the curd undergoes a brief cheddaring until it reaches 0.70% acidity. It is then milled. The key pasta filata step follows, plasticizing and stretching under hot water at 80 to 85 degrees Celsius. The cheese is then molded, brined, packaged, and finally stored. There is also a method for manufacturing mozzarella cheese by direct acidification. This technique involves lowering the pH of the milk directly using different acids, rather than relying on bacterial fermentation. This method helps to eliminate the variability of acid production by bacteria, avoid problems created by bacteriophages, slow starters, and other contaminants, provide better control over pH variations, and significantly reduce manufacturing times. Research has shown that milk acidified to a pH of 5.6 at 4 degrees Celsius with acetic, lactic, or hydrochloric acids can result in a satisfactory product. Calcium levels and the recovery of solids not fat or SNF were higher in pizza cheese made with phosphoric acid compared to those made with hydrochloric or lactic acids. Cheeses made with phosphoric and hydrochloric acids had lower moisture content and were firmer than cheese made with lactic acid. However, the type of acid used had no effect on fat recovery. The flowchart for direct acidification is slightly different. After standardization and pasteurization, the milk is chilled to between 4 and 8 degrees Celsius. It is then acidified to a pH between 5.4 and 5.6 using 25 to 50% hydrochloric acid at a rate of 2.0 to 3.5 milliliters per liter of milk. The milk is then heated to 28 to 30 degrees Celsius. Rennet is added at 0.5 to 0.75 grams per 100 liters of milk. The curd is cut, cooked to 37 to 39 degrees Celsius, and the whey is drained. The curd is then plasticized and stretched under hot water, molded, brined, packaged and stored. The unique stretch of mozzarella cheese is governed by complex chemistry. It is determined by the amount of calcium available for casein cross-linking. The key to producing pasta filata cheese is to simultaneously achieve the appropriate moisture content in the curd and the correct level of casein-associated calcium at the time of stretching. Curd that contains too much casein-associated calcium will tear and fracture during stretching and will not become plastic and stretchable. Conversely, curd with too little casein-associated calcium will lose all structure and stretch when worked in hot water. Both the total calcium content of the curd and the distribution of that calcium between the casein-associated and soluble states are critical. The total calcium content depends on how much calcium is lost to the whey when acid is produced by the starter culture. The distribution of calcium is governed by the curd's pH at the time of stretching. A low pH favors calcium being in the soluble state, while a high pH favors calcium being bound to the casein. In the calcium-rich environment of milk, casein precipitates out as dicalcium paracaseinate, which entraps fat, insoluble minerals, and some sugar. When the pH drops to between 5.2 and 5.4 due to acid development, some of the calcium in the dicalcium paracaseinate dissolves, forming monocalcium paracaseinate. When this compound is heated to 54 degrees Celsius or higher, it becomes smooth, pliable and stringy, and it retains fat well. Therefore, controlled acidification, demineralization, and dehydration, coupled with achieving a critical curd pH at the time of stretching, are the key technological parameters for all pasta filata cheeses. If acidification is excessive, generally below a pH of 5.2, monocalcium paracaseinate will continue to lose calcium and form paracaseinate, which may stretch, but has difficulty retaining fat. The curd generally will not stretch above a pH of 5.6. Packaging is particularly important for the shelf life of mozzarella cheese. The basic requirements for cheese packaging are to exclude oxygen to prevent mold growth and rancidity, and to retain moisture to preserve the texture and avoid weight loss. It is usually vacuum-packed in polyethylene. Irregularly shaped mozzarella cheese is generally packaged in flexible roll films, thermoformable packets, or shrinkable pouches like cryovac. Mozzarella loaves are wrapped with multi-layer heat shrink bags made of materials like vinylidene chloride, such as cryovac S-type. The bags are evacuated and heat shrunk to give a desirable tightness. After brining, the cheese should be dried briefly and then wrapped in parchment, saran, or vacuum-packed in cryovac, polyethylene, or cellophane pouches before being stored at refrigeration temperature. Thank you for joining us for this detailed class on mozzarella cheese. From its humble Italian origins to its status as a global pizza topping phenomenon, understanding the science and craft behind this cheese is essential for any dairy technologist.